All right, so let's go over the answers to the Unit 1 review. Okay, so number 1 says factored completely. So when you see completely, that kind of gives you a clue is it's going to take more than one step to factor this. All right, so if you look at this trinomial, right, there's 3 terms. The first thing we want to say whenever factoring, no matter what, is can I factor out a greatest common factor? So when you look at all 3 of these terms, don't they all contain an x? So let's factor out an x. And then in parentheses, we're going to write what we're left with if we take an x out of each of these terms. Okay, this first term right here had 5 x's being multiplied together. So if I take one of those out, isn't that going to leave me with 4 x's being multiplied together? Which I could write as x to the 4th. Okay, then I'm going to bring this minus sign next to that term. Okay, now I have x to the 3rd. And I took out one of those x's, so that means that would leave me with 2 x's being multiplied together, right? X to the 2nd power. Okay, and then I'm going to take this minus sign and bring it over. And 20x. Well, this x we took out. So it's leaving me with just the 20 to put within the parenthesis. Okay, so now once you factor out a greatest common factor, you always want to look at what you have within the parentheses and say to yourself, well, can this be factored further? All right, well, this is a trinomial, right? There's 3 terms. And whenever the number in front of the first term, right, we call that the leading coefficient, is a 1, that's when you're going to avoid doing the grouping, okay? Does grouping work? Yes, but it's unnecessary steps and more room for error. So what we're going to do instead is, after we bring down that x, we are going to open up 2 sets of parentheses. Okay, whenever there's a 1 in front of the first term of your trinomial, this is where we do the AM method. Okay, so to start, we say, well, what's the square root of this first term? What times itself gives you x to the 4th? X squared, so that's what we're going to put in the first spot in each parenthesis. And then, you may have to do some trial and error, but you need to come up with 2 numbers that multiply to negative 20 and add to negative 1, right? There's really technically a 1 in front of that x squared. All right, so basically we know if it multiplies to a negative, we have to have opposite signs. One of them is going to be a positive and one of them is going to be a negative. So then you have to go through. You can use your calculator to help you if you want. We have to go through all the numbers that multiply to negative 20 and figure out which pair of numbers adds to negative 1. Okay, so just a reminder, if you want to use your calculator, if you have a really hard time doing this, in your head, you could go to y equals and plug in the number we're multiplying to, right? Negative 20 divided by x. And then when you go to your table of values, it lists all the pairs of numbers that multiply to negative 20. So you have to go through one by one and figure out, well, which pair adds to negative 1. So we could see right here, let me see if I can circle it, it's kind of small. We could see that positive 4 and negative 5 add to negative 1. Okay, now, I just want to point out, this right here is fully factored. If this were a minus sign, then that would be a difference of perfect squares. But because of this plus sign, it's not. So we can't factor this further. So it looks like this matches up with choice 2. So choice 2 is our answer. All right, so let's take a look at number 2. Okay, so this says which factorization is incorrect. And I'm going to underline that because sometimes they say which factorization is correct and which one is incorrect. So if you're taking a test, it's always a good idea to underline that. Okay, so let's start off with the first answer choice. This right here, look at this. This is a difference of perfect squares. Now, if you look, right, first thing you want to say is, can I factor out a greatest common factor? No, you cannot. So basically, you set up 2 sets of parentheses, right, like they have here. We take the square root of the first term, which would be 4a, and we put that in the first spot in each parenthesis, so that's looking good. We make 1 plus and 1 minus, and we take the square root of the second term, which is 7, and put that in the second spot in each parenthesis. Okay, so this one actually checks out. All right, so I'm going to just put a little check mark here, right? That one works for us. Okay, let's take a look at number 2. I'm going to do that one off to the side. I need a little room for that. Okay, now this one we have 6 terms. So we know with 6 terms, we're either going to group it into 3 groups of 2 or 2 groups of 3. And sometimes you could look ahead. I mean, I'm looking at this. Look, just look at the numbers. 1, 5, 6, 1, 5, 6. That's going to lead me to believe that I'm going to group it into 2 groups of 3. Okay, when you group them together, one thing I want to really point out, because sometimes I see people do this, sometimes people like to group them by putting a parenthesis around them like that to group them. That, unfortunately, is incorrect. That's going to get points off on a test, because doesn't a parenthesis mean that multiplying these 3 terms by these 3 terms? And that's not what we're doing, right? Isn't this a plus sign in here? Aren't we just adding all these 6 terms together, technically? Okay, so instead of parentheses, I like to group it off just like this. Just using brackets underneath. I mean, you could, if you have some other way you want to do it, as long as mathematically it's correct. Okay, so now, out of these first 3 terms, it looks like the only thing you could factor out is an x. And when you do, you're basically just decreasing each of these exponents by 1. So this is going to leave us with x squared plus 5x to the first, which I'm just going to write as 5x, and then plus just a 6, okay? Because even though this has an x, didn't we take it out? So there's no x left to put here. And again, when you take one x out, you just decrease your exponents by 1. Okay, now out of these 3 terms, I mean, I'm looking, there's not much we can factor out. So when that happens, you have to factor out either a positive one or a negative one. But here, I'm going to be factoring out a positive 1. Okay, so I'm going to write plus 1. When you factor out a positive 1, right, doesn't everything stay the same? So I'm going to rewrite the same exact trinomial within these parentheses. Okay, so now what we do is we take what's in front of our common parentheses and we group them together as one of our factors. And then we take the common parenthesis, which in this case is a trinomial, and we rewrite it once, okay, not twice, just once. All right, now you always want to look and say, well, can I factor further? All right, well, this there's nothing we could do with. Okay, if there's a binomial, we're looking for a difference of perfect squares, which we don't have. Now this is a trinomial. So because the number in front of the x squared is a 1, we just want to say, are there 2 numbers that add to 5 and multiply to 6? Yeah, totally, right? 2 and 3. So I'm going to set up 2 sets of parentheses. And since x times x gives us x squared, I'm going to put an x in the first spot in each parenthesis. And since a positive 2 and a positive 3 add to 5 and multiply to 6, that's what goes there. And then don't forget to bring down your x plus 1 in front. Now, if we look, doesn't this expression right here say the same exact thing as this expression? So this checks out also. So that's not our answer. Okay, so we're going to take a look at number 3. I wrote it over here in a different color, though, so it didn't blend in with choice 2. Okay, so I just wrote the left-hand side of the equation. All right, now if we have 4 terms, we're going to jump into factor by grouping. Okay, so I'm going to group together the first 2 terms and group together the last 2 terms. So out of the first 2 terms, it looks like I could take out an m squared. And when I do, that's going to leave me with an m plus 3 in parentheses. Okay, now out of the next 2 terms, you want to decide whether you want to factor out, it looks like either a positive 4 or a negative 4. Okay, well, I don't know if you see this, but it doesn't look like either one is going to work, because if I take out a negative 4, then in parentheses, that's going to leave me with a positive m, and then 12 divided by negative 4 is negative 3. And if you notice, look, these don't match. Even if I had taken out, let me just erase this for a minute. Even if I had tried to take out, that's not the eraser. So even if I had tried to take out a positive 4, let me just erase this. Okay, so a positive 4. What would happen is, well, a negative divided by a positive is a negative. That would leave me with a negative m and then plus 3 in parentheses. So either way, these parentheses don't match. Those are not equal. So we can't do this one by factor by grouping. It's not going to factor for us nicely like that. So basically, choice 3, that is our answer. That's the one that doesn't check out. But I would always still check the last one because you want to make sure you didn't make a mistake. So if I check number 4, well, let's see, this is a trinomial. Okay, there's no greatest common factor to factor out, and since the leading coefficient is a 1, we would just set up 2 sets of parentheses. We'd put the square root of this first term in the first spot in each parenthesis. So w squared, right, because isn't w squared times w squared w to the 4th? And then we want to come up with 2 numbers that add to, technically 1, right? There's really a 1 in front of this. And that multiply to negative 72. So that'll be positive 9 and negative 8, which is what this says up here. So this one also checks. So choice 3 is our answer. I just wanted to point out also in the calculator again, if you have a really hard coming up with 2 numbers that multiply to negative 72 and add to positive 1, you can go to y equals in your calculator and plug in the negative 72 divided by x. Let me just move this down a little bit so we're not kind of, okay, we're trying to come up with 2 numbers that multiply to negative 72. So you could type in negative 72 divided by x. And then what you'd have to do is you would hit, sorry, I just got to hit this second graph, right? Go to the table of values, and you would scroll up and down until you found a pair of numbers that adds to positive 1. So I actually don't see a pair of numbers on my screen that works yet, but keep going. Well, 8 and negative 9, they add to negative 1, but we want it to add to positive 1. So I'm going to keep going. 9 and negative 8. 9 and negative 8 add to positive 1. So that would be the numbers that I put here and here. All right, so number 3. Now, they want to know which of the following here is this expression equivalent to. Now, I don't know if you notice this, but there's a shortcut. Whenever, see how they say the same exact thing within the parentheses? They both say x plus 3. A shortcut is to bring a different variable into it, okay? What I'm going to do is I use the letter A. You could use whatever you want. I'm going, and you have to say this. If it's a show your work question, you have to write this first, okay? Without this, it's not full credit. Let A equal, and we're going to let it equal what we see in both of these parentheses here, x plus 3. So now what we're going to do is we're going to rewrite this expression. Wherever we see an x plus 3, see how this says x plus 3? We're going to rewrite it as A. So we're going to write A squared, and then plus 6 times, see how this right here again says x plus 3? We're going to replace that with an A, and then I'm going to bring down the plus 5. Okay, so all I did was I rewrote this expression, but wherever I saw an x plus 3, I just replaced it with an A. Now, the reason I did this is because this is an easier, this is an easy expression to factor. Okay, whenever you have 3 terms and the leading coefficient, the number in front is a 1, we just set up 2 sets of parentheses. And I'm going to put the square root of this first term in the first spot in each parenthesis. And we're going to come up with 2 numbers that add to 6 and multiply to 5. Okay, so if 2 numbers that add to 6 and multiply to 5 would be 5 and 1. Okay, now here's the deal. A was not a part of the original problem, right? They were x's. So what we're going to do is we're going to go back and switch these a's to what they actually represent. Doesn't A represent x plus 3? So in place of this A, I'm going to write it as x plus 3. And then we're going to take this plus 5 and just bring it down. Okay, and again, in place of this A, I'm going to write it as x plus 3. That's a 3. And then we're going to take this 1 and bring it down. Okay, and then just combine your like terms. Look, within the parentheses, isn't 3 plus 5 just 8? So this would be x plus 8. And then over here, isn't 3 plus 1 just 4? So this would be x plus 4. And let's see, that matches up with choice 4. I mean, they have it in a different order than we do, but it doesn't matter. When you multiply, right, it doesn't matter what order you put them in. So these are the same. All right, number 4, which of the following is not equivalent to that expression? Okay, well, I think what I'm going to do with that expression is, I mean, I guess technically what you could do is you could just distribute out all the answer choices and see which one is equivalent to this. You know, that might actually be your best bet. It's probably the fastest way to do it too. I'm going to do it a different way though. I'm going to use factoring because that's what our, that's what our topic is here. But, and I want to also underline this word not, which is not equivalent. So 3 of those are this, are equivalent to this expression here. All right, I'm going to take this expression first and let's do factor by grouping. Okay, so since we have 4 terms, right, we know we're going to group together the first 2 and group together the last 2. And out of the first 2 terms, we could pull out an x squared, which leaves us with x plus 2. And then out of the last 2 terms, instead of pulling out a 9, we want to pull out a negative 9. Because if this goes positive, positive, and this goes negative, negative, this has the opposite signs. Okay, in order to get it to have the same signs within the parentheses, when the signs don't match up, we just pull out a negative with it. So I'm going to pull out a negative 9. So in parentheses, it leaves me with x plus 2. All right, now we can group together what's in front of our common parentheses. So I'm going to group together the x squared minus 9. And then I'm going to bring down that common parenthesis once and once only. Okay, now it looks like we're not done because look at this. If you have 2 terms, if you have a difference of perfect squares, we're going to factor that further, okay? We abbreviate that as dots. So we set up 2 sets of parentheses. I'm going to put the square root of the first term in the first spot in each parenthesis. We'll make 1 plus and 1 minus. And we'll put the square root of the second term in the second spot in each parenthesis. And then let's just bring down this x plus 2. All right, so that's fully factored. There we go. All right, so now we want to know which of the answer choices are not equivalent. Okay, so without doing any work, I mean, right away, look at choice 1. See this right here? Doesn't this, I'm just going to kind of draw a little arrow, doesn't that say the same thing as this step right here? I was going to do some work, but I'm not even going to bother. Look, this and this says the same thing as this, and this matches up. So choice 1 is not the answer. Okay, that one is equivalent. All right, let's look at choice 2. Now, if I look at choice 2, I don't see this in any of my steps. But we do know that. See how these say the same thing within the parentheses? Okay, if that's the case, can't we take what's in front of the parentheses and group them? Kind of like what we did here. See here? See how this says the same thing in the parentheses? Didn't we take what was in front of the parentheses and group them together and then just rewrite the common parenthesis once? That's what I'm going to do here. I'm going to take what's in front of our parentheses, the x plus 2. I'm going to put that in one parenthesis. And then I'm going to take my common parenthesis of x squared minus 9 and rewrite that just once. Now, although I can factor this further, right? Although I could factor this to an x plus 3x minus 3 and have it look like this, technically I don't really have to because isn't this expression the same thing as this expression right here? Look, they match up. So you could tell they're equivalent without even completely factoring it. So this is not our answer either. All right, now, if I look here, choice 3, this says x minus 2 and x squared minus 9. Now, let's look over here. It has the x squared minus 9, but this says x minus 2 and this says x plus 2. So these are not equivalent. So choice 3 is our answer, but we always check all of the answers just in case. Okay, and choice 4, well, that one is equivalent as well, because doesn't this right here say the same thing as this, just in an opposite order? So these actually do match up as well. So that's not the answer. So choice 3 is our answer. Okay, now number 5. Wow, this looks like a lot going on here. But before I start, I'm just going to look. We want to know which expression is equivalent to this. Now, if you look at this, right, notice if you see the same expression within the parentheses, we're kind of in the middle step of a factor by grouping problem. Can't we take what's in front of the common parenthesis and group them together? So I'm going to take the x to the 16th, y to the 4th, minus 25, and group them together. I'm just going to kind of write equals in one parenthesis. And then I'm going to take my common parenthesis and rewrite that once and once only. Okay, now if you look at the answer choices, right, I don't see this in any of these answer choices. So that means we could probably keep going. And we can, because look, this is a difference of perfect squares. And same thing here, this is a difference of perfect squares. So let's keep going. All right, so I'm gonna actually kind of need more room. I'm gonna move my equal sign here. So in order to factor this further, I'm gonna need 2 sets of parentheses. Okay, one gets a plus and one gets a minus. And I'm gonna take the square root of this first term and put it in the first spot in each parenthesis. Now be careful. Even though the square root of 16 is 4, when it's an exponent, the square root of x to the 16th, remember when it's an exponent, you just cut that in half, is going to be x to the 8th. So the square root of this first term is going to be x to the 8th y squared. You just cut the exponents in half. So x to the 8th y squared. Okay, and then we're going to look at the second term in each parenthesis. And we're going to say, well, let's take the square root of this and put it in the second spot in each parenthesis. So the square root of 25 is 5. Okay, now, this is also a difference of perfect squares. So let's keep factoring with that. So underneath this, I'm going to set up 2 sets of parentheses. One's addition and one's subtraction. And then the square root of the first term goes in the first spot. So the square root of x to the 4th is x squared. And the square root of the second term goes in the second spot. So the square root of 81 is 9. Okay, now, we still have binomials, right? 2 terms. So we're looking for difference of perfect squares. Now, neither of these are a difference, so those don't factor further. This is a difference, but 5 is not a perfect square, so we can't factor that further. This is a difference of perfect squares, so this is actually going to factor further. Okay, so what we do is we bring down everything that cannot be factored further. And then this last parenthesis, I'm going to break up into 2 parentheses, okay? Because it's dots, we make 1 plus, 1 minus, and we take the square root of x squared and put it in the first spot in each parenthesis. So square root of x squared is x. And we take the square root of the second term, so square root of 9 is 3, and we put it in the second spot in each parenthesis. And guys, that is fully factored. Now, they didn't say, whenever they say equivalent, I mean, it doesn't have to be fully factored. And if you notice here, I'm looking at the answer choices, see choice 4, this right here, doesn't that say the same exact thing as this middle step up here? Okay, so when they say, see this one said equivalent, this says equivalent. It doesn't have to be fully factored. If it said which of the following is completely factored, then they'd have to have this answer there. But choice 4 is equivalent to one of our in-between steps, so that is our answer. Okay, so number 6 says Mrs. Paris incorrectly factored this expression and got these factors. Okay, it says to explain her mistake and determine the correct factorization. So be careful. Explain means you have to put into words what she did wrong. And then after that, we have to show how to factor it correctly. Okay, now, it looks like what Miss Paris did was she said, oh, look, this is a difference of perfect squares. And since the square root of the first term is 2x, she put it in the first spot in each parenthesis. And since the square root of the second term is 10, she put it in the second spot in each parenthesis. And then she made 1 plus and 1 minus. So what did she do wrong? Yep, she forgot to factor out the greatest common factor. If you look at these 2 terms, shouldn't she have pulled out a 4 to start? Okay, so since it says to explain, that means words, right? You got to put it in words. This right here is the explanation. Now, in addition to that, it says, and determine the correct factorization. Okay, so what she should have done first is, since both of these numbers are divisible by 4, she could have factored out a 4. And when you do, it leaves you with x squared minus, well, 100 divided by 4 is 25. Okay, and then if you look here, this is a difference of perfect squares, so we could factor this further, right? So let's first bring down the 4, and then we could set up 2 sets of parentheses. We know one is going to be addition, one's going to be subtraction, and the square root of x squared is x, and the square root of 25 is 5. So there we have it. That is factored correctly. Okay, so it looks like the directions for the rest of the problems is just to factor the following expressions completely. Okay, so number 7. So we have a trinomial. Now, for any expression, the first thing we want to say is, can I factor out a greatest common factor? So I'm looking, we could take out a 2, we could take out a 4. 4 is the biggest number that divides evenly into all of them. So that's how we're going to start. We're going to take out a 4. And when you factor out a greatest common factor, you're basically just dividing all of these numbers by 4. Okay, so 24 divided by 4 is 6. So it's 6x squared. 4 divided by 4 is 1. So you could just write either 1x or just, I like to just write x. And then negative 8 divided by 4 is negative 2. Now, we're going to see if we could factor this further. Since there's a number other than 1 in front of our first term, we do not jump into setting up 2 sets of parentheses, right? This is where we do the rainbow. So let me first bring down the 4. Oop, that doesn't look like a 4. Let's try that again. And I'm going to open up one big parenthesis. Okay, we don't set up 2 separate parentheses. What we do is we bring down the first term, we leave a big space, and we bring down the last term. Okay, so we just bring these down. And then, why we call it the rainbow, right, is we make kind of like a little arc from the first term to the third term. And we multiply those together, which gives us negative 12. So we need to come up with 2 numbers that multiply to negative 12. And technically, there's a 1 in there, and that add to positive 1. Okay, so positive 4 and negative 3. So positive 4, and because there's an x here, I need to stick an x on it. And then negative 3x. All right, so then I'm just going to bring this 4 down and bring down that parenthesis, and let's group these. Now, when you have a GCF and you're doing grouping, once you pull out the greatest common factor out of these 2 terms, you're going to have to open an additional parenthesis. That's okay. So here you could factor out a 2x. And again, we're going to have to open another parenthesis to write what we're left with after we take a 2x out of these 2 terms. All right, so 6 divided by 2 is 3. Oop. And we had 2 x's being multiplied together, but we took one of them out, so we still have 1 to put next to that 3. And then I'm going to bring down the plus sign. 4 divided by 2 is 2. And although this has an x, we took it out, so we don't need to put an x here, so we're going to close up our parenthesis. Okay, so now when we look at these 2 terms, I mean, the only thing you can really factor out is either a positive 1 or a negative 1. But since within the parentheses this is positive, positive, and this is negative, negative, okay, they have the opposite signs. That clues you into, all right, got to factor out a negative. So I'm going to factor out a negative 1. And when I factor out a negative 1, all that happens is the signs here change. Okay, I'm going to be left with a positive 3x and a positive 2 in parentheses, which is awesome because then that matches up with my other parentheses, so I'm on the right track. Now, you know how I open this parenthesis here? I also have to close it at the end. Okay, so we're almost there, actually. So basically, we're going to take this 4 and bring it down. I'm going to take what's in front of my common parentheses, so the 2x minus 1, and I'll group that together. And then I'm just going to take my common parenthesis of the 3x plus 2, and I'm going to rewrite that just once. Okay, not twice, just once. And that is fully factored. Okay, now, when you take a look, I'm going to just change colors so that things don't blend into each other. When you take a look at number 8, I don't know if you noticed this, but you really got to look out for this. See how the exponents are not in descending order? This is not written in standard form. You want to rewrite this so that your biggest exponents come first and it works its way down. So this term right here, and keep the sign with it, the negative 3x to the 5th has the biggest exponent, so we're going to put that first. All right, this term, the positive 30x cubed, has the next biggest exponent. And then this comes at the end, right? This is really a negative 72x to the first power. There's really a 1 as an exponent. So I'm going to bring down the negative 72x. And now our exponents are in descending order. They go from greatest to least. All right, so now let's look. It looks like we could factor some stuff out here. So first of all of these numbers are divisible by 3, and each term has an x. So we're going to factor out either a positive 3x or a negative 3x. Now, remember, you always want to factor out whatever sign the first term has in front of it once it's written in standard form. So since this is a negative, please factor out a negative 3x. Okay, so negative 3. 3 is the biggest number that divides evenly into all three of those terms. And then really, as far as variables go, you just look at whichever one has the smallest exponent, and that's what you factor at. All right, so let's open up a parenthesis. So out of this term, we took the negative 3 out. We had 5 x's being multiplied together, and we took 1 out, so it leaves us with 4 x's being multiplied together. All right, now, positive 30 divided by negative 3 would be negative 10. And we had 3 x's being multiplied together, and we took one of them out, so there's still 2 left that are being multiplied together, so x squared. And then negative 72 divided by negative 3 is positive 24. And although this had an x, we took an x out, so there's no x's left to put here, so we're going to close up that parenthesis. And then we're just going to look within the parentheses. Once you factor out a GCF, you always want to look in the parentheses and say, well, can I factor that further? Well, if we can come up with two numbers that add to negative 10 and that multiply to 24, then yes, we can. Okay, so let me first bring down the negative 3x, open up 2 sets of parentheses. And again, the reason I'm not doing grouping, the reason why I'm setting up 2 sets of parentheses is because the leading coefficient is a 1. See how over here the leading coefficient was a 6? When it's anything other than 1, that's when you do the rainbow. Okay, so anyway, the square root of x to the 4th is x squared. That's what we're going to put in the first spot in each parenthesis. And then here's the deal. If two numbers multiply to a positive, it means they have to have the same sign. So if they have to have the same sign and they add to a negative, right, it means they both have to be negative. And the reason I'm pointing that out is because some of you may have been thinking in your head, oh, I know two numbers that multiply to 24 and add to negative 10, negative 12, and positive 2. But think about it. They don't, although these add to negative 10, these multiply to negative 24, not positive 24. So these, we're going to get rid of. These are not our answers. Okay, so two numbers that multiply to positive 24 and that add to negative 10 would be negative 6 and negative 4. And because we have two terms within our parentheses, we're going to look if anything is a difference, which yes, they both are, of perfect squares. Well, this isn't, but this, both of these are, so this can factor further. So basically, we're going to bring down whatever cannot factor further. And then I'm going to factor this using dots. So I'll set up 2 sets of parentheses. One has addition, one has subtraction. And the square root of x squared is x, so that comes first. The square root of 4 is 2, so that comes second. And if you look in your parentheses, there's nothing that factors further. So this is the answer to number 8. All right, now number 9, we have 6 terms. When we have 6 terms, usually you're not going to have to rearrange anything. You're going to jump right into factor by grouping. So with 6 terms, we could either group it into 3 groups of 2, or I guess I'll just do this kind of underneath it. 2 groups of 3. So we're either going to go with the pink or the purple. Now, I'm going to start by looking at the pink. I could tell right away that's not going to work for us because see how, like if I were to group these two, isn't 8 smaller than 26, right? The number in front of the first term is smaller than the number in front of the second term. Look at these. The number in front of this term is bigger than the number in front of that term. So if I were to try to factor out the greatest common factor here, I would not be left with the same thing on my parentheses if I factored out the greatest common factor here. So if that doesn't make sense to you, you could try it out. I mean, factor out the greatest common factor here, see what you're left with. Factor out the greatest common factor here, see what you're left with, and you'll see they don't match. Okay, if you could see that ahead of time, you can just go ahead and erase that. Okay, so now it looks like out of these first 3 terms, really, the biggest number that divides evenly to all of them is a 2. And then in addition, we could take out an x. So we're going to pull out a 2x. Okay. And when we do that, it leaves us with 4x squared minus 13x minus 12. Okay. Now out of these terms, looks like we can factor out a 5. Now you have to decide, am I factoring out a positive or a negative 5? Well, this is how you tell. See how the signs in here go plus, minus, minus? And these do the opposite. They go minus, plus, plus. When they do the opposite, that's when we factor out a negative. So we're going to plot a negative 5. And when you do, just divide all those 3 terms by negative 5. It also leaves you with a 4x squared. Oop, let me rewrite that. It's supposed to look like a 4. And then minus 13x minus 12. All right, well, the good news is, look, our parentheses match. So we could take what's in front of the parentheses, the 2x minus 5, and we can group them together. And then we could take that common parenthesis, in this case it's a trinomial, and we can rewrite that. Now the first parenthesis, okay, if you look, it's not going to factor further. It's not a difference of perfect squares. This one, though, because there's a number other than 1 in front of the first term, we're going to have to do the rainbow, the whole factor by grouping process, and see if we can factor this further. So to start, let's just bring down the 2x minus 5. And then I'm going to, let's see, I'm going to open one huge parenthesis and bring down the first term, bring down the last term, and we need to come up with 2 numbers that multiply to 4 times negative 12, multiply to negative 48. Okay, so it's a multiply to negative 48, and at the same time add to negative 13. Okay, so if you want to do, by hand, great. If not, in the calculator, you would type in the number we're multiplying to, negative 48 divided by x under the y equals, and then you would go to the table of values, right? Second graph. And you just look up and down the table until you find a pair of numbers that adds to negative 13. Now I'm looking at what I have on top here, negative 3 and positive 16. Well, if you have more positives than negatives, that's going to add to a positive. These two add to positive 13. So if I reverse the signs, look right here, 3 and negative 16, right? Don't those add to negative 13? So there we go. And you can write whichever one you want first. I'm going to put the negative 16 first, but it doesn't really matter. So negative 16 and positive 3. And what these 2 numbers need on it is whatever this middle term has on it. So if it's an x, we put an x. If it's a x squared, we put an x squared. If it's an xy, we put an xy, but that's just an x. So we're going to put just an x here and here. Okay, so let's bring down the 2x minus 5. And then we're going to group. So out of the first 2 terms, we could pull out a 4x, which leaves me with x minus 4. Out of the next 2 terms, I could pull out a positive 3, which also leaves me with an x minus 4. And then let's bring down this 2x minus 5. And I'm going to take what's in front of our common parentheses, so the 4x plus 3, and group them together. And then let's take that common parenthesis of x minus 4 and rewrite that just once. Okay, and this is our answer. There's nothing else within those parentheses that can be factored further. All right, and we are finally on to the last one, number 10. Now, you see 4 terms. Right away you think with 4 terms, well, let me start grouping. Now watch what happens. If I were to group and group, some of you might see what's going to happen right away. If you look at these, right, the only thing you would factor out of these 2 terms would be a 2, which would leave you with 10x cubed, minus y cubed. Now out of the next 2 terms, right, you could factor out, I guess, just an xy, but there's no way that's going to leave you with the same thing in the parentheses. So what that means is we got to come up with a plan B. So I'm going to erase this. Now, some of you may have noticed this. Remember, when you have an expression, you want to write it in standard form. And what that means is if you have more than one variable, you look at whichever variable comes first alphabetically. Doesn't x come before y in the alphabet? You want the exponents on the x's to go in descending order. So see how this is x to the 3rd? That goes first. See how this is x to the 2nd? That term's going to go second. See how this is x to the 1st? That term's going to go 3rd. And see how this says no x's? You could say x to the 0. That term's going to go at the end. That's going to go last. Okay? Okay, so again, what I did was I looked x to the 3rd, right? You're looking you want to put these in standard form according to the exponents on the x's. So you want these x's. You want the exponents on the x's to go in descending order. So the positive 20x cubed went first. The positive 8x squared y went second, right? Because x to the third, x to the second. Then this is the term that contains x to the first power. So the negative 5x y to the second comes third. And then finally the term without any x's comes last. And at this point, let's do grouping and let's hope that they match up. And by the way, I want to point out with grouping, if you can factor out a greatest common factor, you still want to always do that first. Okay, so out of the first two terms, it looks like we could factor out a 4 out of the numbers as well as an x squared, right? You want to see which one has the lower exponent. This has the lower exponent, so that's what we'll take out, a 4x squared. And when we do, that's going to leave us with 5x plus 2y. All right, now to the next two terms, we're definitely going to have to factor out this negative, right? Because we want it to be positive within the parenthesis. And other than that, the only thing they have in common is y's. Look for the smaller exponent, which is this, y squared. So we're going to factor out a negative and then y squared. Okay, and then when I do, that leaves me with, let's see, the negative pulled out, so we still have a 5, we still have an x, and that's it, we pulled the y squared out, so we have a 5x. And then here, a negative divided by a negative is a positive. Okay, we didn't take out the 2, so let's leave that. And we had y to the third, but we took 2 of them out, so we still have another y to put with that, too. And actually, look at this. This is great because our parentheses, again, match up, which is a good feeling because then you know, look at this, I'm on the right track. All right, so we're going to take what's in front of the parentheses, the 4x squared minus y squared, and we'll group that together. And I'm going to rewrite the 5x plus 2y. All right, now look at this. This is dots. It's a difference of perfect squares. So we could factor this first parenthesis further. Okay, so we know with dots, one gets addition, one gets subtraction. The square root of 4x squared would be 2x. And then the square root of y squared would just be y. And we can bring down the 5x plus 2y. It doesn't look like anything else can be factored further. So there we go.